Okay, radicals. Radical. Okay, so rational to radical form, you need to be able to go back and forth. So this right here, it's called a rational exponent because rational it's like a fraction. Notice that the n, so whatever's in the denominator goes outside, whatever's on the numerator goes up top. And these two are the exact same thing. They're just different ways of getting there. Okay? Or different ways of writing the same exact thing. So here, just remember, bottom goes in the V, and the top goes on the outside. Okay? So if we had x to the 1/2 power, well, bottom goes in the V, and the 1 goes on the outside. And if you write something to the first power, it's just, you don't have to write it. And we used the square root so much, that's just the same as the square root of x. Okay, if we do like x to the 1/3 power, that's the same as the cube root of x. If you use x to the 1/9 power, that's the same as the 9th root of x. X to the 3/7, well, the 7, so the denominator goes in the V, and the numerator goes on the outside, so that's the same as, or we could rewrite it as x to the 1/7 to the 3rd power, which would be the 7th root of x cubed. You could also write this as x cubed to the 1/7 power, which would be the 7th root of x cubed. Those two things say the same exact thing. I do not care which way you do it. I don't care. Whatever way makes more sense to you, awesome, go for it. Okay? Prime factorization. So remember, prime factorization, you probably made like these factor trees. Like if you were to take 72, that's 9 times 8. 9 is 3 times 3. 8 is 2 times 4, which is 2 times 2. And then you look at the bottom. So the prime factorization of 72 is 3 times 3 times 2 times 2 times 2. Okay? And we use this to simplify radicals. So this right here is wrong because 280 is not 140 times 140. It's 140 plus 140, but we're not doing it with addition. It's always with multiplication. Okay? So if we want to simplify 252, I'd say I'm doing this two ways. I'll just go through it. 252 is the same as 2 times 126. 126 is the same as 2 times 63. 63 is the same times of 7 times 9. And then 7 times 9 is the same as 3 times 3. And notice here, I grouped my 2's together, I grouped my 3's together. Since this is a square root, I just need 2 2's, 2 of anything, and I can pull 1 out. So I can pull out a 2. I can also pull out a 3, and then 2 times 3 is 6. Let's do this one. So this one's a cube root, which means that instead of groups of 2, I need groups of 3. So 128 is the same as 2 times 64, which is the same as 8. 64 is 8 times 8. And then 8 is the same as 4 times 2, so I just did that twice, which 4 is the same thing as 2 times 2. So I have 2 times 2 times 2 times 2 times 2 times 2 times 2. Then I just get groups of 3, so I have 2 groups of 3 2's. So I can pull out that purple one, and I can pull out a blue one. And then I can multiply the outside, so negative 5 times 2 times 2 is negative 20 cube roots of 2. If you prefer the factor tree, that's fine. Let's do it. So this time I need a group of 4. That little number in the V tells us what we need. So that's 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So I have 4 2's right there. So I can pull one of them out. So that's going to be 2 times 2, 4th root of 3, which is 4 4th roots of 3. Simplify your radical, you must. Always, always simplify your radicals, okay? Adding and subtracting, I would always simplify first. Okay, always simplify first. So let's simplify the 32. That's 2 and 16, which is 4 and 4. I have a pair right there, so I can stop. So then 18 is 2 and 9, which is 3 and 3. So then that's going to be negative 5 times 4 square roots of 2 plus 2 times 3 square roots of 2. So that's negative 2 square roots of 2 plus 21 square roots of 2. They're exactly the same. So you can always add radicals if they're the same. Okay, it's a lot like if we had like negative 20x plus 21x, I could add those and get 1x, right? But if I had negative 20x plus 21y, I can't add those. That still equals negative 20x plus 21y. Okay, same thing here. If this was a square root of 3, then I couldn't have done anything. But since it's not, I can combine these to just be 1 square root of 2, which is the same as the square root of 2. Okay, let's do this one. So again, we want to simplify this. And negatives can always be pulled out of cube roots. They cannot be pulled out of square roots. And the reason it can be pulled out of a cube root, if we take negative 1 times negative 1 times negative 1, you get negative 1. So you have a group of 3 there. And then I just did the prime factorization of 56, 2 times 2 times 2 times 7. And I end up getting negative 2 cube roots of 7. Do the same thing with 189. And I end up getting 3 cube roots of 7. So then that's going to be negative 3 times negative 2 is positive 6 cube roots of 7 plus 3 cube roots of 7, which is 9 cube roots of 7. Cool. You must be the square root of negative 1 because you can't be real. So if you take, I'm going to get into this next time, and you've probably remember doing this last year, but remember the square root of negative 1 equals I. Whoa, that was the weirdest I I've ever tried to draw. I. So you can take the square root of negative 1 is I, but the cube root of negative 1 is negative 1. Okay? Multiplying radicals. So first let's simplify this. So square root of 18 is the same thing as 3 square roots of 2. Square root of 20 is the same thing as 2 square roots of 5. So that's going to be, outside with outside, inside with inside. But before I get to that, so that's negative 3 square roots of 2. 2 times 2 is 4, so times 4 square roots of 5. Now, when you multiply radicals, it's always outsides with outsides, insides with insides. So negative 3 times 4 is negative 12. 2 times 5 is 10. And so then it's just negative 2, or negative 12 square roots of 10. And then we could do this just right from the beginning if we wanted to do outsides with outsides, insides with insides. So negative times 2 is negative 2. 18 times 20 is 360. And if we break down the 360, we get 2 and 180, 2 and 90, 2 and 45, 3 and 15, 3 and 5. So we have 2's we can pull out, 3's we can pull out. So that's negative 2 times 3. Inside we have 2 times 5. Well, 2 times 3 is negative 12 square roots of 10. Notice you get the same exact thing. So it doesn't matter if you simplify at the beginning or not. I recommend you always simplify at the beginning though. Okay, this is my recommendation. That was really good handwriting. It says recommend. Okay. Again, outsides with outsides, insides with insides. You can simplify first. I don't know if I did. Oh, looks like I didn't. Okay, so 7 times 3, and then we have 3 times 15, x times x cubed, and y squared times y. So that's really 7 times 3 is 21, 3 times 15 is 45, x times x cubed is x to the 4th, and y squared times y is y cubed. Then we can see what we can pull out. Well, 45 breaks down to 3 square roots of 5. X to the 4th, we have 2 groups of x's, and y cubed, we just have 1 group of y's, and we have 1 left inside. So I can pull out a 3, I can pull out 2 x's, and I can pull out a y. So then, and I'm left with 5 and a y inside. So 21 times 3 is 63, x times x is x squared, y, and inside we have 5y. Okay, this one. So this is a lot like, you multiply these the same way as if it was like 5 minus x and 7x plus 1. Okay, you could distribute, you could use the box, whatever. Same thing here, you could distribute, you could use the box. I think I probably used the box, yep. So 5 times 7 square roots of 2 is 35 square roots of 2. 7 square roots of 2 times negative square root of 2 is negative 7 square roots of 4. 1 times 5 is 5, and 1 times negative square root of 2 is negative square root of 2. Now that 7 square roots of 4, well, 4 is the same thing as 2 times 2. So that is really negative 7 times 2, which is negative 14. Okay, so if I pull all that out, we have 35 square roots of 2 minus 14 plus 5 minus the square root of 2, which ends up being 34 square roots of 2 minus 9. Okay, dividing radicals and rationalizing denominators. So rationalizing means that we're just getting radicals out of the denominator. Radicals, we don't like radicals in the denominator, and we don't like imaginaries or complex numbers and negatives. Okay, those are the three things we always kind of want to rationalize and get out of that denominator. So let's break down. The square root of 48 is the same as 4 square roots of 30. And the square root of 6 is just the square root of 6. So then if I pull that out, I end up getting 24 square roots of 30 over 2 square roots of 6. Well, 24 divided by 2 is 12, so that's 12 square roots of 30 over 6. Now, if I want to get rid of that square root of 6, one does not simply leave an answer without rationalizing the denominator. True. So I'm going to multiply by square root of 6 to top and bottom. So that's going to be 12 square roots of 180. And then 6 times 6 is 36. Well, that one was easy. That's just going to become 6. That's why we multiplied by the square root of 6. But then 180, oh, and then 12 divided by 6 is 2, so we can simplify that. 180 breaks down to 2 times 2 times 3 times 3 times 5, which means I can pull out a 2 and a 3. So that's end up going to be 12 square roots of 5. End up going to be, that was really good grammar. Wow. You're welcome, guys. Okay, so here, 7 cube roots of negative 32 over 2 cube roots of 4. Well, let's simplify that. Negative 32 ends up being negative 2 cube roots of 4. So we have 7 times negative 2 cube roots of 4 over 2 cube roots of 4. Notice that we have a 2 cube roots of 4 on top and bottom, so I'm just going to cancel them right there. And so I end up just getting negative 7. Okay, that's the reason why I would always simplify, especially when dividing. Always simplify when dividing, because something might cancel out and it'll make your life easier. Okay, this one. So let's simplify everything inside. So 288 divided by 2 is 144. J to the 5th, K to the 3rd. Well, 144 breaks down to 3 times 2 times 2 times 2 times 2. Oh, wait. So we have this. These are all, just look at the ends of these. So that's, wait, I'm struggling. Sorry. There. And then we have this group right here, which is why I circled the group. Okay, but we're left with 3 and 3 and 2. Okay. And then J to the 5th, we have one group of 3, and K cubed, we have a group of 3. So then I can pull out 1, 2, I can pull out a J, and I can pull out a K, and I'm left inside with 3 times 3 times 2 times J, which is 2JK cube root of 18J squared. Okay? Now these ones, when we're rationalizing these denominators, we're going to multiply by what we call a conjugate. Okay, so conjugate, the definition is give the different form of a verb in an inflected language. So like Spanish, you can conjugate verbs, as they vary according to voice, mood, tense, number, and person. So we're changing something here. Okay, so the conjugate of these in math is you change the middle sign. Okay, you don't change the first sign, you always change the middle sign. So the conjugate of -1 minus square root of 3 is -1 plus square root of 5. I said square root of 3, but I meant square root of 5. That's what I'm going to multiply to top and bottom. And I can do that because it's the same as just multiplying by 1. Okay. Now, the top is going to be easy to multiply. The bottom, let's just use the box. Our square root should end up dropping. So I get 1, square root of 5, negative square root of 5, and negative 5. Those square roots are gone, so 1 minus 5 is -4, and that's what I'm left with in the bottom. On the top, I just distributed it, and I got -4 plus 4 square roots of 5. And then notice that -4 can divide into both of those, so I'm really just left with 1 minus the square root of 5. Okay, let's do one more. So multiply by the conjugate, which would be 5 minus the square root of 4. Now, if I do the bottom there, I end up getting 5 minus 16, which is negative 11. I'm going to use the box for the top also, and you end up getting negative 7 minus the square root of 5 over negative 11. Okay, so however you multiply it, you could distribute, whatever. I think you guys know how to do that, so I'm not going to go through all the math. But then notice here how we have that negative in the bottom. We don't like that. So we're just going to multiply everything by negative 1, which just switches all the signs. So 7 plus square root of 5 over 11. Okay? Okay, so let's do these ones. We want to write it in simple radical form, simplest radical form. Notice how those are all the exponents are over 3. So I can just pull out a 1/3, which means that I can change this. If something raised to the 1/3 power is the same as the cube root, so it's the cube root of 27r to the 17th s to the 8th. Then we just break that down. And you could do all this. So you end up getting 3r to the 5th s squared, and then cube root of r squared s squared. Okay, just simplifying it the way that we have been. This one in simplest rational form. So remember that whatever's in the v becomes your exponent's denominator. So that's 5k cubed to the 1/4 power. And then that just comes into both of them. So that's the same as 5 to the 1/4 k to the 3/4. Okay, this one, so 4y cubed, square root of 4y cubed. Well, we can put that little 2 there to help us. And then that becomes whatever's in the v becomes the denominator. And then whatever's on the exponent inside is the numerator. So that's the same thing as 4y to the 3/2 power. Which 4 to the 3/2 power is 8. And then y to the 3/2 is just y to the 3/2. Okay. Let's go through these ones real quick. So simplify these. If we have g to the 3/4 times g to the 5/2, well, the bases are the same and we're multiplying, so that means we're going to add those exponents. So 3/4 plus 5/2. 5/2 is the same as 10/4. So that's going to be g to the 13/4. Then we want to write it in radical form, so that's the same as the 4th root of g to the 13th power. Okay, then I can pull out g cubed and I'm left with just a g inside. Okay, this one, so 1/2 is the same as the square root. Then if we simplify that square root, I'm left with 4a cubed b square root of b. Okay, this one, so we have m to the 3/2 over m to the -2. Well, when you're dividing, or let's not even divide, if you have a negative exponent, it could flip up to the top, so this negative exponent just comes up. So that's the same as m to the 3/2 times m squared, which 3/2 plus 2 is the same as 3/2 times plus 4/2, which is m to the 7/2, which is the same thing as the square root of m to the 7th. Okay, then you can pull out an m cubed and you're just left with the square root of m. This one, so if we have an exponent raised to the exponent, you multiply those. So that's the same as 20 over 15, which is 4/3, and then we can rewrite that as the cube root of w to the 4th. Almost finally, we can pull out a w there. So this would be w cube root of w. And then finally. Sorry that that's kind of long. I hope you powered through. Okay, bye.